Today we have a 61 Impala quarter panel. This is the rear of the 61 that we're building. This car has had extreme damage and it has a lot of sections that are very tricky to make, especially if they're from scratch, because you can't buy any panels for this car. You can get a couple small patch panels. The only one that I've actually seen is from here forward. We actually ordered it, but the problem is all of these creases and body lines are not even matching even remotely close. Started thinking about past classes that I've had and how we were going to make these shapes. A lot of times we don't really have the game plan until we jump in and we start having to problem solve. In this case, back in the day, I took a class with Gene Winfield. Gene Winfield makes what they call the Winfield Anvil. And it's nice because you can make a lot of these shapes. I actually didn't realize how handy that it was going to be until we just made it last week. And we've been using it for all kinds of stuff on the 64 and now with this one. So how we came to using that and picking what size tubing that we used was actually with radius gauges. These radius gauges are the radius gauges you get with the JRM planishing hammer. Jason Millard's setup. And what we did was we took a 1.5 radius gauge and we figured out that is what the radius of this area needs to be. Now, this is for the radius, so a diameter tube, we picked a 3-inch tube. So if this is a 1.5 radius gauge, then we obviously need a 3-inch diameter tubing. So what we did when we built this anvil is we picked 3-inch, 4-inch for the big center piece, and then we used 1-inch on the other side for any other small projects that we may have. Because you can, even though that those radiuses are already into the anvil, we can actually take that anvil and slip it through to create all kinds of different shapes, and that's what we're going to show you guys today. So with a piece of scrap, this is 18 gauge, and this 18 gauge for thickness wise is about 35 thousandths thick, give or take. This anvil, when we make it, we used a paint stick for the distance in between each one of the pieces of tube. Obviously we used a pretty thick sidewall, and then we made all this stuff super stout. We put it on casters so that way we can move it around the shop wherever we need. The other thing that we took into account is we made sure that we made it a little bit longer than 4 foot. That way you can take a full 4 foot size sheet metal, stick it through here. You could bend around for a trans tunnel. You could use it for a variation of things. When I first saw this in Gene's class, I didn't really understand how much it would be used until I started this business, and then we had all of these different situations where we had to come up with making it from scratch. Between this and a sheet metal brake, and I mean you could even have a cheapy Harbor Freight, Pittsburgh, whatever it is brand you want to get brake. Between those two things, we can make all the shapes for the most part on this quarter panel that we need. So I just wanted to show you guys with the piece of scrap how easy it is. It slips in. You can put something, like I said, as thick as a paint stick through here to bend. Obviously, the thicker, the lot harder it's going to be to bend, but maybe you use a torch to assist it. But it's nice because with ease, you can create really nice radiuses for both. This would be a 1.5 because you got a 3-inch tube. And then on this side, maybe you want to go the opposite direction with a piece of 1-inch. And very easily you can start creating different shapes. So if we take that, we're going to pan back over here. If we take that and we put that into our panel, we can see that that is a perfect radius match for our quarter panel. And even if you need to finesse something where you're just slightly working it and you're moving the panel in, you can create a lot bigger of a radius if you needed to, especially with that 4-inch piece of pipe. This is all Schedule 40, by the way. Can't remember Schedule 40 or Schedule 80, but it's really thick wall. It's about 1/4 inch thick. So if the thicker you get, the more you can put some leverage into it. The other thing that's nice is you can also drill a spot through between the two. And if you had solid bar, maybe a 1/2 inch solid bar stock, you could use that if you wanted to create hooks. Like we're gonna build a welding cart. We got 1/2 inch square rod that we're gonna be able to put in there and then bend that around for some really nice hooks. You can use it for all different kinds of things. Maybe you use the end cap for shaping and you have your big wooden hammers that you can put the piece of sheet metal here and smash it into the end cap. Tons of different variations of uses. Once you have one, you realize how many different ways you could do it. And if you don't have a welder, you could always bolt these together and put spacers with washers, whatever works for you guys. If we know we can create that radius right there, it's that easy to be able to figure this out. Now, a lot of these panels have shape. Well, what is shape? Shape is a panel that has curvature in more than one direction, and a formed panel is something that is only curved in one direction. In this case, this is just formed because we're just bending it in one direction on a plane. Now, what we're going to do is we're going to be making the patch. This was what the gas filler door was, and when we took it off the car, whoever had welded this patch in actually welded and left all of the gas door structure. And for most of you, that might be fine. But why is the reason that we're doing it? The real reason is that if you leave the inner structure in there, you have no way of hammer and dolling that weld and getting rid of the warpage from the welding. Now, you can MIG this, you can TIG this, but I will tell you the one benefit there, if you TIG this, is it is a lot softer of a weld that you'll be able to work the warpage out. No matter what method you're going to weld this with, whether it be TIG or MIG, you are going to get a level of warpage. It's just the technique. If you're going to MIG it in, then you're going to be wanting to use the air like we've had in our MIG welding video and doing it very slow moving around. For TIGging it, we're going to be doing the same process where we tack weld everything all the way in every 1/2 inch, and we're going to make sure our fitment is perfect before we continuously weld it. The other thing I want you guys to notice is that our patch panel has all rounded edges. The reason that we round all of our edges is because when we are metal finishing out the welds, having a circle with no lines that are going in one direction, like right now, just to cut it off the car, I cut a square. But if we think about what we're going to be doing with hammer and dolly work, we're going to be stretching and shrinking to get this to a mirror like we've already started working on the back section of the panel. These intersecting each other at a hard point, it will never want to metal finish out, where having it be a circle, in a sense, you can work that out because it's continuous. You're not working on two different planes trying to level out your welding. Because the thing is, as you weld this, whether you're MIGging or TIGging it, that is going to be inconsistent. Even the best TIG welders will have some level of inconsistencies in their welds. And I'm not perfect, and this will allow me to TIG weld this panel all in and then work out any of the warpage damage. If you're very proficient TIG welder and you can keep it nice and cool, then obviously your hammer and dolly work is going to be to a minimum. We are going to show you how to do this today, all by hand, hammer and dolly. We're going to TIG it in. We don't have the lenses today to go over in depth on TIG welding. We will be doing a TIG welding video sometime in the future, but really I have not perfected it to the point where I would feel comfortable to show you guys. I don't have a certification on it or anything like that. So until I feel very proficient in it, and I don't think that I'm bad, but I want to make sure that I dial in what I know and what I know that works. That way we can produce the video. So until then, we'll go into the details of a TIG welding video. But we do have one on MIG, and we are going to TIG this in. So the big thing that we need to make sure that we're going to do is this radius. Obviously, we don't want to put that line on the bar. We want to make sure that we have this going into the Winfield Anvil square. So I am going to be placing this up here and getting a visual of roughly how much that's going to be in. The other thing we're going to be using is a profile gauge. This profile gauge, you can buy these on Amazon, you can buy them online, but all it is a bunch of needles that you can move in any one direction for that shape. What's nice about this is I can take where the panel is good and I can press this in here and I have the exact shape that I need from the side profile. Well, why is this important? Well, if we know we have the radius right here and we match it up, I can actually use this to place my mark on where my Sharpie bend is going to be for the brake. If I put a tick on each end of this, I can get the radius, and let's say that I needed the gas door patch to go up into the top and include that bend. I can mark all of that on the piece that I'm going to be bending and then break the top edge to get that up over. The other thing that's nice about the profile gauge is that if you have to make a bigger shape and maybe you don't have a 3-inch, maybe you have a 2-inch pipe on your anvil, you can sit there and finesse that piece and then figure out with your profile gauge, do I have it right on the money or do I need to bend it back the other direction? You can get it right with this and then just slap it in the car and you're going to have the right shape. So we're going to be using the 3-inch for this curvature here, and I'll be using the 4-inch to just finesse out this curve. A lot of times we would use a planishing hammer, but we're filming this at night and I don't think my neighbors would appreciate that. So we will work all this out by hand. All I'm going to do here is mark our patch panel with a rough area of where that bend is going to be. We already know we have enough excess that I can always cut it off if need be. So here we're going to be utilizing the radiuses, and what I'll be doing is once this is bent, I'll press it into the radius, we'll scribe it, and then we will cut it and use a barrel sander to get that exactly fit in there, and then we'll just tack it as we go. So I'm just going to use an adjustable square to get a rough area that is straight. That way the reason that I do this is because when you align it into the anvil, you don't want this to be kicked one way or the other. Sometimes you might, like earlier today, I used it to build the steering column brace for the 64 Malibu. And in this case, I want it to be straight and in line with the quarter panel. So I'm just going to be putting this line through this entire panel. That way I have a reference parallel to the tubes before I bend it around. This Sharpie mark is just for my point of reference from the top side. This will end up being the back side of this panel. So again, we're looking at it and we're just checking to make sure that if I center that bend, we're going to be okay. And just do little bits at a time. Obviously, we need to go a little more. Now that's pretty close right there already. And even though you can see I've got this longer, I've already raised top, I'll end up chopping this down. I can Sharpie the back side and then we'll just radius this edge just shy to where I can come in here and do that. I might even, because I don't have enough of a lip here and I still have to be able to metal finish this out. That is so close and I really don't want to have to mess with this edge if I don't have to. So what I'll end up doing is getting everything scribed in, and I'll probably hold this on here and scribe this panel from the backside so I can not have to cut more out of the panel. I can use where it's thicker to my advantage and just cut this exactly to the top shape. Overall, that's pretty amazing for something so simple to fit that good. Now what we're going to do is, again, we're going to make a reference now for, you can see everywhere there is no light on the quarter panel. But where do we start curving the other direction is really what we want to mark. So right here we have a little tiny tick that I have no air gap, and right where I start to see the air gap, I'm going to put another scribe line through the panel. Now we're going to use the 4-inch side. So when we put this in here, I'm going to be bending this just shy, because remember, this bottom piece does not have much surface area. It's not going to take a ton of bending, and I think we might need a little bit more on the 3-inch. That's better. The whole goal here is that when you actually weld this panel in, that you can set the panel in and it fits the shape relaxed. You do not want to force it into place, because what will happen is if you're using, say you're using the edge of your hammer and you're pushing on one corner and you're welding at the same time, it's under that tension. So as soon as it heats up, it's going to want to push that tension everywhere else on the panel. And when we're trying to get a mirror finish in the metal like that, you need to try to get this exact. Obviously, this would be better if, say this is a 48-inch radius, which I'm pretty sure it is, I already looked with the radius gauge. At this point, I could take the planishing hammer and just run this through the planishing hammer to create that 48. I would just take it with a gauge, figure out what you need, and then put that 48-inch radius die in your planishing hammer and work that panel back and forth until you can put the gauge on there and it's a dead nuts fit. In this case, I'm going to get it really close by just forming it only in one direction. And when I actually take the weld out, we'll get the weld out by hand, and most likely tomorrow I will planish this section right here out so that shape is absolutely perfect. Dude. So right there, our panel is super close. Now, obviously, I don't know if this shows up in the camera or not, but this crease is a little bit excessive. I don't like to bend things back, because a lot of times that curve, when it gets bent the other direction, you'll have a low spot. But this one is such a slight bend. I want to massage that in there evenly, so that way we don't have as much hammer and dolly work to do. So you just slip it up a little bit, give it a little bend, slip it up a little bit, give it a little bend. That way you have something that's a little more uniform. That's pretty much it right there. I just want to center this, press it up in there firm. Now I can get rid of that whole top section, and then we'll grind down to where we're closer. We'll end up holding this in there and scribing the backside. So we're going to be using a Dicom. This thing's pretty cool. It's like a big old Sharpie. And then we're going to be using a scribe for marking our line. Can you use a Sharpie? Yes, you can. But when it comes to TIG welding, 90% of it is fitment. So the better I can get this to fit a TIG, a MIG. Obviously, if you're in MIG and you're trying to transition to being a TIG welder, I would say practice your fitment. Practice to where you have 0 gaps to where that butt weld fits, and then you're not battling. Because the thing is, if it fits perfect, the TIG welding part of this is not that big of a deal. But what's cool about this is this end, you can just paint it on. So is it better to take it off of the panel, or is it better to shave down your patch? Well, placing this up here and scribing it is a lot easier to just remove it from the quarter panel. But obviously I want to utilize that area right here where they had it welded being so little of a surface area, I need it to be away from this edge so we don't affect this radius. I started touching on it, but what the real reason is to get rid of the inner structure is because if you body work this thing with filler, and even if you have it to where you have almost little to none warpage with MIGging it and then doing it really cool, the problem is because this all has tension behind it and there is some level of shrink no matter what welding you're doing, if you body work over that, you will see a ripple in the body filler. So in this case, we're going to paint the back of this. That way I can get a nice perfect cut for the top of that hole. And because I know I need this to fit perfect first, I'm going to scribe that first and have Mike go back there and scribe that. You can Clecos this in to hold it, magnets, whatever, but for something so small, it's a lot easier to just have your buddy help you. Let me hold it nice and tight. Go ahead.
Just the top.
Yep. Good. So now we have a very perfect line that we're going to cut in there first. And I'm going to go ahead and do that. And then where these lines end for my square, I'm going to bring them all the way out. And I'm going to round these edges. That way I can keep this continuous circle that we can work all the warpage out with. So I'm going to go back there, cut this right to the scribe line, and then we'll place it back in there and move forward. So here we're just aligning it side to side so that way I can get my gap perfect, and then I'm going to put a couple Sharpie marks just so I have a reference point side to side before we move forward. So now we have this edge, it's shy of each end, and we are just going to take that scribe in there nice and tight. If you have trouble holding this thing in place, definitely use a Clecos. Just going over it really thorough, so I make sure I get it good. The better you scratch it, the easier it is to see. And if your dicum wears off or it gets hot as you grind, that scratch mark will still be there. There we have it. Our scribe mark continues right where we are. We're going to grab an air saw and we'll buzz the bulk of it out, and like I said, we will use a small barrel sander to just come in there and dial in every one of these radiuses so we can make this thing fit perfect. These air saws, they will throw it right back in your eye, so definitely make sure you either have a good eye doctor or a face shield. Don't get that. We've gotten everything really, really close to the scribe line, and I just want to make a mental note for you guys that are newer to using air tools and pneumatics, that a lot of times, well, not a lot of times, all the time, I never run any air tool full kill wide open. I am always sitting there using my other hand to stabilize, and a lot of times I will even smash my finger just on the edge a little bit, so that way you have more of a cushion and more control. You want to be using this thing where you can sit there and make that gap perfect. If you're just over here with one hand, your gap is going to be all over the place because you have no control. You want to creep up on the scribe line, whether you're using the barrel sander or whether you're using the die grinder. Always have two hands to stabilize, and like this one, you can see I always smash my index finger just a little bit so that way I'm not going all the way open. And then once we have it to the point where all we have is just a little bit of excess, I'll use the rat tail file. This one's a half round, half flat, and I'll just dial this in so that way we can drop the new panel in and we won't have any air gaps. And these are just a whole bunch of little tiny, I think they're earth magnets is what they call them. It fits. So we've got it fit in the hole perfectly. And now that we have the side profile right here, this one needs to be a little bit more roundy above this line. We bent this curve, and there's a small section just right here that we need to add a little bit more shape into. So we're going to use the 4-inch and just bring that out a little bit more. Now the gaps are perfect. We're going to go back through, we're going to remove this. We're going to remove any of the blue dicum so we have a nice clean weld. You also want to make sure that when you guys are grinding and or filing, you're not filing at an edge, you're filing where the edge of the sheet metal is perpendicular. You want a nice square edge, because if you are using a die grinder on an angle, what will happen is you just made the edge where that butt weld is going to be a thin edge, and as soon as you strike an arc, whether it be MIG or TIG, it's going to blow a hole right through it. So I know there's guys that will take a cutoff wheel, an air saw, and they will set it at a 45-degree angle and they will cut the panel in. Yeah, you can do that, but I find that if you're not proficient with welding, it's more problematic, because what you're doing is you're putting a 45 bevel on both sides, and now you have two thin spots. Yes, they're mating. Does it make a huge difference? Not really. Do whatever works for you guys. This is just what works for us, and this really is more in line with doing a high-end finish on a panel. I want to be able to remove this area like this never existed and have this same finish when we're done. That's the goal. So if there is any more shape, remember shape being two directions, then I can bring that in there and hammer and dolly that out. As we hit each time with the hammer and dolly, we're going to be stretching to make sure this fits. So I'll clean that up with a strip disc. This is the strip disc. They sell these for this 3-inch roll lock. These are nice because you're not removing material. Again, if we only have, call it 34, 35 thousandths of an inch to work with when we weld, the last thing you want is to make it thinner when you already had metal. So this is not going to be removing any material. This is going to be a different challenge if you're welding to a piece that is really pitted or thinner, because as the metal has eroded, you're going to introduce more problems that are harder to weld. That's a lot of times. If we have a car that's super rusty, I'll end up having to remake the whole panel, because you would end up spending more time trying to weld to subpar metal than anything overall. Here's a disclaimer for you guys. Anytime you're using blue dicum, make sure you're not putting it over a sandblasted surface, and that if you do use it, you're getting all of it off. If you have a car that's already sandblasted and you want to use it, take a DA to the panel and get rid of that profile that's left by media blasting. Because if it's left anywhere in the porous areas, no paint is going to stick to that dicom. Brake cleaner will also work to remove any of the dicom. You guys got to give Mike a lot of credit, because half the time he's like, oh, we're done filming, and then I come back in and I add one more thing. Oh, I already moved the camera. Oh, we missed that one part. We try to be as detail oriented as we can, but sometimes we miss some things. Because a TIG welder is melting everything together just like a MIG would be, but it's doing it differently. A MIG welder, as you strike an arc, it is feeding the wire and it's melting instantly when you do that. A TIG welder, you're actually melting your base material, and you are hand feeding in your filler rod, and you are fluctuating your amperage with your foot pedal. As you do this, if you have paint or primer on the backside, it will bring it up into this joint and it will weld like absolute crap. If you're like me, you're thinking about every scenario you could have, like say you're gapping a door. Well, where your outer skin and your inner structure is, usually you have surface rust in there. It's not fun to weld. So it just depends on what level your work you're doing. We have already cleaned this entire panel of any primer anywhere on the back side, the front side, for this reason. So we put it on the jig that we made, the wooden buck, so that way we have rigidity, so this panel isn't moving around on us. And you can flip this panel 360 degrees in any direction. That way I can work it from an area that maybe you can't get. A lot of guys are asking, well, how do you hammer and dolly an area that you can't get? This is the extent that that is. Take every single spot weld out, so that way you can get to it, make it perfect, and then put it back on the car. Very, very extensive process. It is not for everybody. We've got the panel, patch panel in place. We've laid the quarter panel down, so that way I can get over it and I can work underneath as well as above it. But some of the things that you're going to want to have to consider when you're tack welding this panel in is, no matter what, we've touched on this, if you're welding, it is shrinking. What happens with that perfectly fitted butt weld is that when you tack it, that spot in the heat affected zone, so the gas shielding around it and where you can see the heat go around the weld, what happens is it is going to expand upward. And then what happens to the weld is, as it cools, it does not matter if you let it cool by the ambient air temperature that day. It does not matter if you stop the heat with air and cool it fast, or a wet rag. What I want you guys to understand is that no matter what, you are going to have some level of shrink. Depending on how good your welding is going to directly affect how much warp you're going to get out of that panel. So what happens is you heat it. When you heat metal, it is rising up, it is stretching, okay? And as it cools, what you have to know is that the heat input that you put in, so depending on your welder settings, depending on your technique, whether it be MIG or TIG, what's going to happen is it's going to cool and come back down flat, and it's going to cool and shrink just below. So what you end up with is this V right in the weld seam. And what I see a lot of guys do is they will grab a hammer and they will go up the backside and they will work that weld out, and they think that they're stretching it. But what you have to understand with this exact thing is that you're not really stretching it. What you're doing is you're pushing something that has shrunk into a V, and you are pushing it back up. Well, what it has to do is it has to gather that metal from somewhere. So somewhere in that panel, laterally, it's pulling that sheet metal on itself. What you have to do is you have to know that if you weld, you are shrinking it. So if your panel is perfect before you start and you weld it, don't run to hammer and dollying the whole panel, trying to fix all the warp. All you have to do, because the panel is going to take off, and depending on how good you are, it's going to take off on more than others. All you have to know is if it fit good before you welded it, and then you welded it and you have a lot of warp, all you have to do is hammer and dolly, hammer on dolly, meaning hammer is directly in place with the dolly on the weld seam, and you are going to picture it like pizza dough, okay? Your weld seam is pizza dough. You have to roll that back out and stretch it back out. Well, how do we do that? We hammer on dolly the weld, and the weld itself that might be, I'm just exaggerating this. Let's say it's this big and it's a big bulky MIG weld. MIG weld versus TIG weld, we're gonna get to that. But if you have a weld and it's so thick, you have to smash the weld down. And what is that doing? It is displacing the metal outward 360 degrees from that area. So you work that weld back out. You are stretching the weld, you're flattening the weld, and that is displacing the metal 360 degrees around that hammer head. Depending on your hammer, if you have a hammer that's square, it's spreading the metal in 4 directions. If you have a round hammer head, it is spreading it 360 degrees. That is the analogy that I want you guys to take away from that, is that even when you're tack welding, you're just trying to get the panel to align, right? So if we have a butt weld that's fitted like this, and then you tack weld, you are taking a cloth over that area, and where you tack weld it, it is pulling inward on that area 360 degrees. So all you have to do to reverse that is just hammer dolly the area that you are going to weld. So what we're going to do is we're going to tack weld that around every 1/2 inch, and as we tack weld, things are going to start to move and not line up. So we're going to hammer and dolly a little bit as we go on all of those tack welds. Now here's the caveat that I want to tell you guys. If you are going to MIG weld your panel in, can you hammer and dolly it? Yes, you can, but the MIG weld itself is a lot harder. It's a lot more brittle, and depending on how much penetration you are getting all the way through the panel, you could potentially crack that area. A lot of times that happens because guys MIG weld it. Well, now you have that big profile of the weld. You've got to face that thing and grind it back down. Now you don't have much structure, and because it's harder, as soon as you hammer and dolly it, it cracks. So TIG welding is superior to MIG welding in this respect, but maybe you don't have the panel off the car and you have no access to hammer and dolly that. Well, that would be the perfect scenario, is tack weld and cool each tack with your air and do it slow so you don't get a lot of warpage. You are going to get some warpage, but if you're stopping that shrink from happening in the weld, you're eliminating a whole bunch of warpage. If you go at it and you're just welding that whole panel around, the whole panel is going to sink in because it is directly connected with how much heat input you put in that panel. If you heat it, it's going to shrink. That's all there is to it. Now that we're fully welded out, we'll come through and we'll face all of the bulky areas of the weld. Obviously, TIG welding, you have a lot less of the bulk than you would have with a MIG weld. So here along this edge, we'll just basically go through with the roll-lock with I like to take a 36 grit first just to get the very tips off. And because we're going to metal finish it, we don't want excessive scratches. So I'll make sure I have both 36 grit on the roll-lock and 80 grit. And then when we get close, what the biggest part here is we working this up. You're smashing the weld and bringing it up. Everybody thinks that you take the area that's low and you hit it and push it up. But actually, when you're hammer on dolly in the low area, it will start to take the shape of the dolly. That's why you need to match the dolly with the shape of the panel. And what's happening is, as you start to face that weld, you can then hammer and dolly and bring it a little bit farther out. And then you'll be able to face the weld a little bit more. And then hammer and dolly, bring it a little bit more out until you have that perfect faced finish. And at that point, we will then start laying the dicum. We're going to spray the blue layout fluid over this whole area and take a block, and we'll just block an area, and we'll start working it until it's a perfect mirror. And then we will grind it with the same way we did over here with a big shrink disc grinder, and we'll come out and we'll finish all this all out. The other thing is, as you weld this, when you get done welding it, we welded this in small sections, anywhere from 1.5 to 2 inches at a time. Now you are creating more warpage by doing that, and then I would cool that area so I could keep working it instead of it just taking off. This panel does have quite a bit of warpage in it. Well, why does that happen? Because anywhere that we're not a perfect robotic machine and we have a little bit more heat amperage, maybe you blew a hole, maybe your welding is not the perfect, and maybe your fitment is not perfect. So the more that you have of those issues where you have more heat or more weld, you're going to have more shrink. And then when you feel it, it's pulling in 360 degrees in that area of that weld. So what it's doing is it's bunching up. So everybody will start working up here where the warpage is. You just need to work out the weld. And when you work out the weld, smashing it, it will then relax this. It's that fine line. It's a finesse. You have to have finesse with the hammer and dolly to be able to know how hard you're hitting it and how soft you hit it, to whether you want to move it a lot or a little. And then you basically just keep blocking, hammer and dolly, block it until you can see the blue start to disappear, and then you start creating that mirror that you want at the end. I hope this gave you guys a very clear, defined path on doing a proper replacement panel. Again, there's a million different ways you can do this. This is just our way, and this is what we teach in our classes. So hope you guys enjoyed this process. It is a lengthy one, and really the fitment part is the most important part. 80 to 90% of what you do is all fitment. The welding, the hammer and dolly, obviously you got to have a little bit of skill, but finessing that through is really the key to a nice, perfect mirror. Anyways, we'll see you guys on the next episode. Hope that helped you.